I want to tell you something about the future that physics has known for more than a century and that has still not fully entered the public conversation. Something that, when you understand it precisely, changes not just your abstract sense of the universe, but the felt texture of what it means to be alive in it. The future already exists, not as a possibility, not as a potential, not as one of many branches that might unfold depending on what choices are made, as a physical fact, as real as the chair you are sitting in, as concrete as the moment you are reading these words. The events that have not yet happened in your experience are already present in the structure of the universe. I want to be precise about what this means and what it does not mean, because the claim is often either dismissed as poetic exaggeration or inflated into something mystical that physics does not support. The claim is neither poetic exaggeration nor mystical. It is a direct consequence of the mathematics of special relativity, confirmed by a century of experiment, and its implications for how we understand time, consciousness, and the nature of existence are profound. The framework in which this claim lives is the block universe, sometimes called the eternalist view of time. In the block universe, the four-dimensional space-time of special and general relativity is the fundamental reality. Every event, past, present, and future, exists at its space-time coordinates with the same ontological status. The division of events into past, present, and future is not a division that exists in the space-time structure itself. It is a feature of the perspective of an observer moving through the block, experiencing events in sequence along their world line. Let me build this up from first principles, because the claim is only compelling if you understand the physics that supports it. The first principle is the relativity of simultaneity, which I derived in the time dilation video. When two observers are in relative motion, they disagree about which events are simultaneous. An event that occurs at the same time as another event in one observer's reference frame occurs at a different time than that other event in a reference frame moving relative to the first. Let me derive this from first principles because it is the key step in the argument, and it is more counterintuitive than most presentations make clear. Consider a thought experiment. You are standing at the midpoint of a train car. The train car is at rest. Two lightning bolts strike the two ends of the car simultaneously in your judgment. You know, they are simultaneous because you are at the midpoint, and the light from both flashes reaches you at the same moment. Since you are equidistant from both ends and the light arrives simultaneously, the strikes must have been simultaneous. Now consider the same scenario from the perspective of someone on the platform watching the train pass at velocity v. In their frame, the train is moving to the right. The light from the lightning strike at the front of the train and the light from the strike at the back are both moving at c in the platform frame, but the train is moving to the right while the light is traveling. The observer at the midpoint of the train is moving toward the light from the front and away from the light from the back. To the platform observer, the light from the front strike reaches the train midpoint before the light from the back strike does. But the train observer says both flashes arrive simultaneously at the midpoint. How can they disagree? They disagree because the strikes were not simultaneous in the platform frame. In the platform frame, the back lightning strike must have occurred earlier than the front lightning strike, so that by the time the light from both strikes meets at the moving midpoint, the light from the back has had more time to travel. The two strikes that are simultaneous in the train frame are not simultaneous in the platform frame. This is the relativity of simultaneity. It is not a failure of the observers. It is not a measurement artifact. It is a genuine physical asymmetry. The causal structure of space-time is such that the events that constitute right now for one observer are genuinely different events from the events that constitute right now for another observer in relative motion. The magnitude of the simultaneity shift is determined by the Lorentz transformation. The time coordinate of an event in the prime frame moving at velocity v along the x direction relative to the unprimed frame is t prime equals gamma times the quantity t minus v times x divided by c squared, where gamma is 1 over the square root of 1 minus v squared over c squared. The simultaneity shift for two events at the same time t, but separated by distance x in the unprimed frame is delta t prime equals gamma times v times x divided by c squared. For small v and moderate x, this is approximately v times x divided by c squared. Let me give you the specific numbers, because the abstraction obscures how dramatic the effect actually is for cosmological distances. Suppose you are on Earth, and an alien is in a spacecraft traveling at a velocity of 1% of the speed of light relative to Earth at a distance of 10 billion light years away. The spacecraft is moving away from Earth. In your reference frame, right now, is a specific moment. The alien in the spacecraft also has a plane of simultaneity associated with there right now. But because the spacecraft is moving relative to Earth, the alien's plane of simultaneity is tilted relative to yours. The time difference between what I call right now and what the alien calls right now for an event at a distance of 10 billion light years is delta t equals v times d divided by c squared, where v is the relative velocity, d is the distance, and c is the speed of light. For v equal to 1% of c, or 0, 1c, and d equal to 10 billion light years, we get delta t equals 0. 1c times 10 billion light years divided by c squared equals 0.0. 1 times 10 billion years divided by c, which equals 100 million years. The aliens right now on Earth is 100 million years different from your right now. Not 100 million years in the future or past of the alien's experience, but 100 million years displaced in the cosmic time coordinate relative to your plane of simultaneity. 1% of the speed of light is approximately 3,000 kilometers per second. The orbital speed of Earth around the Sun is approximately 30 kilometers per second. A spacecraft at 1% of the speed of light is moving 100 times faster than Earth in its orbit, which is significant but not relativistically extreme. Particles in the Large Hadron Collider move at 99.9999991% of the speed of light. A spacecraft at 1% of c is cruising at a leisurely pace by particle physics standards. Yet for events at cosmological distances, this tiny velocity produces a difference in simultaneity of 100 million years. The alien watching Earth from 10 billion light years away at 1% of the speed of light says that right now on Earth is a time 100 million years before or after what I say right now is, depending on the direction of the spacecraft's motion. If you were to walk across the room right now, changing your velocity by a few meters per second, your plane of simultaneity at 10 billion light years would shift by approximately 1 year. A casual walk across a room changes what is simultaneous for you at cosmic distances by a year. This is the physical magnitude of the relativity of simultaneity, and it directly implies the block universe. There is no universal now. Different observers at the same location, moving at different velocities, have different nows. The events that constitute now are different for each of them. If some events are now for one observer and not for another, then now cannot be the criterion for existence. The events exist for all observers, regardless of whether they constitute that observer's now. This is the argument. The relativity of simultaneity derived from special relativity, which is confirmed to extraordinary precision by experiment, implies that now is observer dependent. If only what is now exists, then different observers have different realities, which is untenable. The only consistent resolution is that all events exist, regardless of their relationship to any observers now. This is the block universe. Let me now describe the block universe picture in detail, because it is both the clearest implication of the relativity of simultaneity and the most counterintuitive conclusion for anyone who takes their own experience of time seriously. In the block universe, space-time is a four-dimensional manifold. Every event, every point in space at a particular time is a point in this manifold. The manifold is not evolving. It is not unfolding. It exists all at once as a complete geometric structure. Your life is a world line in this block. The world line is a curve in the four-dimensional manifold, passing through the space-time point of your birth at one end and the space-time point of your death at the other. Every moment of your experience corresponds to a point on this world line. The moments are ordered by the proper time along the world line, which increases monotonically from birth to death. But all those moments exist simultaneously in the block, in the same sense that all points on a line in Euclidean geometry exist simultaneously. The point that is 10 centimeters along the line does not become real only after you have moved 10 centimeters. It is already there, already part of the line, regardless of whether you have traversed it. In the same way, the events of tomorrow are already points in the space-time block. They are already there, already part of the four-dimensional manifold, regardless of whether you have traversed them along your world line. The sensation of time passing, the felt experience of moving from now toward the future, is not the future becoming real as you approach it. It is you moving through a space-time that is already complete. The block universe view is sometimes called eternalism, and it contrasts with two alternative views. The first alternative is presentism, the view that only the present moment exists. Past events have ceased to exist and future events have not yet come into existence. The only real things are those that exist right now. The second alternative is the growing block theory, the view that the past and present exist but the future does not yet. The universe is a block that is growing at the leading edge, the present, as new events come into existence. Presentism and the growing block theory have obvious intuitive appeal. They match the felt experience of time. The past is gone, the future is not yet here, only now is real. But both have severe difficulties in the context of special relativity. Presentism requires a universal present moment, a cosmic now that defines what exists, but special relativity shows that there is no universal present moment. Different observers disagree about which events are simultaneous. If only what is happening right now exists, and observers disagree about what is happening right now, then different observers would have contradictory ontologies. What exists for one observer would not exist for another. This is not merely a difference in perspective. It implies that the very same event either exists or does not exist depending on who is asking the question. The growing block theory has a similar problem. If the universe is growing at the leading edge of the present, that edge must be universal. All of space-time up to the present moment exists. All of space-time after the present moment does not. But special relativity requires that the present moment be different for different observers. The edge of the growing block must be in a different place for different observers. If the block is growing, it must be growing into territory that already exists in some sense. Or the different observers' blocks are not the same physical reality. The block universe resolves these problems. In the block universe, there is no universal present moment, no growing edge, no ontological difference between past, present, and future events. All events are equally real. The sense of temporal ordering, the sense that some events come before others, is a property of the causal structure of the space-time manifold, not a feature of their existence or non-existence. Let me make a specific point about the physics of this that is often missed in popular discussions. The claim that the future already exists is not a claim about determinism, it is a claim about existence. Determinism is the claim that the future state of the universe is completely determined by its present state and the laws of physics. If the laws of physics are deterministic, then in principle the future could be calculated from the present state with perfect accuracy. If the laws of physics are non-deterministic, as quantum mechanics suggests, then the future is not completely determined by the present state and the laws of physics alone. The block universe claim is independent of determinism. Whether the future is determined or not, whether quantum uncertainty makes the precise state of the future unknowable or not, the block universe claim says that the events that will occur, whatever they are, already exist in the space-time manifold. The space-time block is not a deterministic prediction of the future from the present. It is the complete four-dimensional structure in which every event, however it came about, already has its place. This is a subtle but crucial distinction. A deterministic block universe would be one in which the future is not only already there, but is predictable in principle from the present. An indeterministic block universe would be one in which the future is already there, but its specific content cannot be derived from the present state alone. The indeterministic block universe is consistent with quantum mechanics. The quantum state of the universe evolves according to the Schrödinger equation until a measurement occurs, at which point one outcome is realized and becomes part of the block, but which outcome is realized is not determined by the pre-measurement quantum state. The block universe picture does not eliminate free will in the sense that some fear. It does not mean that your choices are predetermined and that you are merely going through motions that were already scripted. It means that your choices, whatever they are events in the space-time block. The fact that your choice of what to have for dinner tomorrow already exists in the block does not mean your choice is not freely made. It means that the act of making the choice is a physical event that has its place in the space-time structure. The freedom of the choice is compatible with the existence of the choice in the block. Whether free will is compatible with a deterministic block universe is a harder philosophical question. Because in a deterministic block, the content of every event, including every choice, is in principle derivable from the state of the universe at any earlier time. But the existence question and the determinism question are separable, and the block universe addresses the existence question without necessarily resolving the determinism question. The evidence for the block universe picture is the same evidence for special relativity itself. Every experiment that has confirmed the time dilation predicted by special relativity, every measurement of the relativity of simultaneity, every test of the Lorentz transformation is evidence that the space-time block is the correct description of the universe. The block universe is not an additional hypothesis added on top of special relativity. It is the natural, ontological interpretation of the mathematics that special relativity requires. Let me now describe the most concrete piece of evidence for the block universe, which comes from the direct experimental measurement of time dilation. I described the Hoffele-Keating experiment in the time-stopping video. Atomic clocks flown around the world on commercial aircraft showed the time dilation predicted by special relativity. The moving clocks ran slower than the stationary clocks by the amount predicted by the Lorentz formula to within the experimental uncertainty. The moving clock accumulated less proper time during the journey than the stationary clock. What does this mean for the block universe? The two clocks have different world lines through the space-time block. The stationary clock's world line is approximately straight in the space-time block. It moves mostly in the time direction with small spatial displacement. The moving clock's world line is tilted. It makes a detour through space during the journey around the world. The proper time along each world line is the length of that world line in the Minkowski metric, which, as I described in the time-stopping video, is maximized for the straight world line and shorter for the detoured world line. The fact that the two clocks show different elapsed times when they are brought back together is direct evidence that the space-time block has a non-Euclidean geometry, that different paths through it accumulate different amounts of proper time, and that the aging of a physical system, including the decay of unstable particles and the ticking of atomic clocks, is determined by the geometry of its world line in the block. This is the block universe measured in a laboratory. The Hoffele-Keating experiment is not an argument for the block universe from theory. It is a measurement of a consequence of the block universe's geometry. The space-time block has the Minkowski geometry, and different paths through it have different length. The fact that different clocks accumulate different proper times is the direct experimental confirmation of this geometry. Particle accelerators perform similar measurements continuously. A muon produced in a cosmic ray interaction in the upper atmosphere travels downward at approximately 99.9% of the speed of light. Its rest frame lifetime is approximately 2.2 microseconds. In the 2.2 microseconds of its proper time, it would travel approximately 660 meters before decaying. But it is observed at the Earth's surface, having traveled approximately 10 kilometers through the atmosphere. Its lab frame lifetime is approximately 22 microseconds, corresponding to a gamma of approximately 10. The extended lab frame lifetime of the muon is direct evidence of time dilation. The muon's world line in the space-time block is a specific path from the production event in the atmosphere to the detection event at the Earth's surface. The proper time along this world line is 2.2 microseconds. The coordinate time along this world line, measured in the lab frame, is 22 microseconds. Both are real measurements. Both are features of the space-time block. The muon ages by 2.2 microseconds in the proper time of its world line, while 22 microseconds pass in the lab frame. The block universe is not a philosophical addition to special relativity. It is the interpretation of its mathematics made physical by the direct observation of time dilation. Now let me take you to the deepest implication of the block universe, which is what it says about the nature of the present moment and the experience of time passing. If the block universe is correct, the present moment is not ontologically special. The present is not the boundary between the existent past and the non-existent future. All events exist with equal reality in the space-time block. The present is simply the current location of the observer's world line, the event on the world line that is most recent in the observer's proper time. This raises an immediate and serious question. If the future already exists, why don't we experience it? Why does our experience move forward in time from past to future rather than in any other direction or all at once? What is the physical basis for the felt flow of time, the sense that now is special, that the past is fixed and the future is open? I described the thermodynamic answer to this question in the previous section. The arrow of time is a consequence of the low entropy initial conditions of the universe. But there is another dimension to the question that connects more directly to the experience of consciousness, and it is worth developing separately. The neuroscience and philosophy of consciousness suggests that the experience of the present moment, the sense of being alive right now, is produced by specific neural processes in the brain that integrate information over a window of approximately 2 to 3 seconds. The sense of now is not an instantaneous snapshot, but a temporally extended processing window. The brain constructs the experience of the present from sensory data, motor commands, memory retrieval, and predictive models over this window. The felt flow of time, the sense that moments are continuously passing from future to present to past, is similarly a construction of the neural apparatus. It is not a direct perception of an objective temporal flow in the physical world. It is a feature of how the brain processes information from the environment, integrates it with stored patterns from the past, and generates predictions about the near future. In the block universe picture, this construction of the present by neural processes is itself a physical event in the space-time block. The neural processes that produce the experience of now are located at specific space-time coordinates. The experience of now is the physical state of the brain at those coordinates. The sense of time passing is the sequence of states of the brain along its world line, each state in the sequence constructing the experience of now from the integrated information available at that moment. The felt flow of time is real in the sense that the neural processes producing it are real physical events. But it is not a perception of the universe flowing from past to future in the way that a rock flowing downstream in a river is a physical fact about the river. The universe is not flowing. The universe is the space-time block, static in the sense that all its events are already fixed at their space-time coordinates. What is moving is the observer's perspective through the block, the accumulation of proper time along the world line, the sequence of neural states that construct the sense of temporal flow. This distinction between the universe being static and the observer's experience being dynamic is one of the most important and most frequently misunderstood aspects of the block universe. The block universe does not imply that nothing happens, that all experience is an illusion, or that change is not real. Events happen. Changes occur. One physical state causes another. The causal structure of the block is real. What is not real in the block universe is the idea that the universe itself is moving or changing in time. The universe is the block. The motion is the observer's traversal of the block. Let me now connect the block universe to the specific question of free will more carefully, because this is where the emotional stakes of the block universe picture are highest for most people. The fear that the block universe implies fatalism, that my choices are determined in advance and therefore meaningless, is a specific version of a broader philosophical problem called the consequence argument. The argument goes like this. In a deterministic block universe, the events of my future are already fixed in the block. Those events include all my future choices and actions. If those choices and actions are already fixed in the block, then they are not within my control. If they are not within my control, then I am not morally responsible for them. And if I am not morally responsible for them, then free will is an illusion. There are several responses to this argument, but the most important is to question the premise that fixed equals uncontrolled. In the block universe, your future choices are indeed fixed. In the block, in the sense that they have specific space-time locations and specific contents. But they are fixed at those locations because of the causal processes that produce them. And one of those causal processes is your deliberation, your reasoning, your actual exercise of whatever decision-making capacity you have. The block universe picture is compatible with a specific and important sense of free will called compatibilism. In compatibilism, free will means that your actions are caused by your own mental states, specifically by your own reasoning, values, intentions, and desires, rather than by external coercion or compulsion. Compatibilist free will does not require that your actions be uncaused. It requires that they be caused by you. In the relevant sense of the word you, in the block universe, your future choices are already fixed in the block, but they are fixed there because the causal chain that passes through your deliberation and decision produces them. The fact that they are fixed in the block does not remove you from the causal chain that fixes them there. You are part of the causal structure of the block. Your deliberation is a real physical process that produces real physical effects. The choices you make are yours in the compatibilist sense. They are caused by your mental states, not by some external constraint. The block universe becomes more philosophically challenging if you accept a strong form of determinism. If every event in the block is in principle derivable from earlier events by deterministic laws, then your choices are ultimately derivable from the state of the universe before you were born, and the sense in which they are caused by you rather than by the initial conditions is attenuated. This is the hard problem of free will, and it is a genuine philosophical puzzle. But the block universe does not add to this puzzle. The question of whether determinism is compatible with free will exists equally in a block universe and in a universe where events emerge moment by moment. The block universe changes the metaphysical picture, but does not change the logical relationship between determinism and free will. What the block universe does change is the sense of permanence. In a universe where only the present exists, the past is gone and the future is not yet here. In the block universe, the past is permanent, the events that have occurred are fixed in the block at their space-time coordinates, as real now as they were when they occurred. This permanence has a specific emotional implication that I want to develop. The 12 principles in my book include thinking about permanence and impermanence in exactly this way. The relationship between the physics of the block universe and the human experience of loss, memory, and meaning. Ready to change how you see the world? Get 12 principles for understanding the fabric of reality at realityprinciples.com. This is one of the deepest questions in the physics of time, and it does not have a complete answer. Let me describe what physics can say about it and where the mystery remains. The space-time block, with its four-dimensional geometry, does not itself contain a preferred direction of time. The laws of physics at the fundamental level are mostly time-symmetric. They are the same whether you run time forward or backward. Let me be precise about this time symmetry because it is often stated loosely. The electromagnetic equations, Maxwell's equations, are invariant under time reversal combined with charge conjugation. If you reverse all velocities and negate all charges, the equations are satisfied. A video of two charged particles interacting electromagnetically and then reversed in time looks exactly like another valid solution of the electromagnetic equations. Newton's mechanics is completely time symmetric. The equations F equals ma and the law of universal gravitation are unchanged if you replace t with negative t. A video of two billiard balls colliding, run backward, shows a valid trajectory under Newton's laws. A video of the moon orbiting Earth run backward shows a valid solution of Newton's gravity. Quantum mechanics, in the standard formulation, has a subtle time asymmetry in the measurement process. When a quantum measurement occurs, the quantum state collapses to one of its eigenstates with a probability given by the Born rule, and this collapse is not a time-reversible process. This is related to the arrow of time in a deep way, but is not itself the source of the macroscopic arrow of time. The weak nuclear force violates CP symmetry, the combination of charge, conjugation, and parity. And by the CPT theorem of quantum field theory, this implies a small violation of time reversal symmetry. But this CP violation is tiny and affects only specific decay processes of kaons and B mesons. It is not the source of the macroscopic arrow of time we experience, which is billions of times more pronounced than the weak CP violation. The macroscopic arrow of time, the direction in which broken eggs don't reassemble, in which coffee cools but doesn't spontaneously heat up, in which we remember the past and not the future, comes from the second law of thermodynamics. The second law says that the entropy of an isolated system tends to increase over time. Entropy is a measure of the number of microscopic configurations compatible with the macroscopic description of the system. A state with all the gas molecules in one corner of a box has far fewer compatible microscopic configurations than a state with the molecules uniformly distributed and is therefore much lower in entropy. The specific quantitative statement of the second law is due to Boltzmann. The entropy S of a macrostate is K times the natural logarithm of the number of microstates, W compatible with that macrostate, where K is Boltzmann's constant, approximately 1.38 times 10 to the minus 23 joules per Kelvin. A glass of water at room temperature has an entropy of approximately 23 joules per Kelvin. The same amount of ice has a lower entropy, approximately 20 joules per Kelvin. When the ice melts, entropy increases by approximately 3 joules per Kelvin. The second law is not a fundamental law of nature in the same sense as Newton's laws or Maxwell's equations. It is a statistical law. It says that systems evolve toward higher entropy states because there are overwhelmingly more high entropy states than low entropy states. A system moving randomly through its phase space is overwhelmingly likely to move toward higher entropy simply because there are so many more high entropy states available. The specific direction of time that we experience, from past to future, from low entropy to high entropy, is the direction in which the second law holds. We age, coffee cools, eggs break, and we remember the past because entropy increases in the direction we call future. But the fundamental laws of mechanics that govern the microscopic behavior of the molecules do not distinguish past from future. The second law is an emergent law, arising from the statistical behavior of many particle systems and from the initial conditions. This last point is crucial. The second law holds in the direction we call future because the initial conditions of the universe were in a state of extremely low entropy. The Big Bang was not just a hot, dense state. It was a hot, dense state with extraordinarily low entropy, a specific kind of smooth homogeneity that corresponds to the minimum entropy configuration for a gravitating system. The contrast between the initial low entropy and the current higher entropy is the physical origin of the arrow of time. Systems evolve from the initial low entropy state toward higher entropy states because that is the direction that statistical mechanics favors, starting from the specific initial conditions we have. If the universe had started in a high entropy state, entropy would increase in both time directions symmetrically, and there would be no preferred arrow of time. The initial low entropy of the universe is the past hypothesis, and its origin is one of the deepest open questions in physics. Why did the universe begin in such an improbably low entropy state? The probability of a random initial state having the low entropy of the Big Bang is fantastically small, of order e to the minus 10 to the 123, a number with 123 zeros in the exponent. Several proposals have been made to explain the past hypothesis. Roger Penrose, in his book The Road to Reality and elsewhere, argues that the low entropy of the initial state is a special feature that requires a cosmological explanation, and he developed conformal cyclic cosmology in part to provide such an explanation. In CCC, the very low entropy of the Big Bang of our aeon is explained by the conformal rescaling that connects the previous aeon's heat death to our aeon's beginning, which resets the degrees of freedom and creates a new low entropy state. Sean Carroll and others have proposed that the past hypothesis can be explained by eternal inflation. The full inflationary spacetime has high entropy, but the bubble nucleation that produces our observable universe creates a low entropy pocket within it. The specific mechanism by which inflation produces a low entropy initial condition in the observable universe involves the smoothing of density fluctuations during the inflationary phase, followed by the creation of structure through the amplification of quantum fluctuations at the end of inflation. The mystery of the past hypothesis connects directly to the block universe. In the block universe, the space-time manifold is not generic or random. It has a specific structure with a specific geometry, specific initial conditions, and a specific thermodynamic gradient. The arrow of time that we experience is a feature of the specific block we inhabit, not of the abstract space-time structure itself. In a universe with different initial conditions or no low entropy initial state, the felt flow of time might be different or absent. What the block universe does illuminate is why the arrow of time feels the way it does. The asymmetry between past and future in our experience is not a feature of the space-time geometry itself, which treats the time direction only with a sign difference from the space directions in the Minkowski metric. The asymmetry is a feature of the thermodynamic structure of the specific region of the space-time block that we inhabit, specifically the region that evolved from the low entropy Big Bang. If we lived in a region of the space-time block that had evolved from a high entropy state toward a low entropy state, our experience of time would be reversed. We would remember what we call the future and anticipate what we call the past. The words past and future would refer to the opposite directions. The felt direction of time is not built into the space-time geometry. It is a product of the thermodynamic gradient of the region of the block we inhabit. This is a deeply strange and somewhat vertiginous conclusion. The direction in which time flows for us, the direction we call from past to future, is contingent. It is not a feature of the fundamental structure of space-time. It is a feature of the thermodynamic history of the observable universe, which started from a low entropy Big Bang and has been evolving toward higher entropy ever since. In a universe that started from a high entropy state, or in a region of the block far from any thermodynamic gradient, the felt flow of time might not exist at all. The 12 principles in my book include this: the difference between what feels fundamental and what actually is fundamental is one of the most important distinctions physics teaches. The arrow of time feels fundamental. It feels as if the past and future are different in kind, that the past is fixed and the future is open, that time flows in a specific direction because that is what time does. But physics reveals that this felt fundamentality is a thermodynamic contingency. Ready to change how you see the world? Get 12 principles for understanding the fabric of reality at realityprinciples.com. Let me now address the most common objection to the block universe, which is the claim that it is inconsistent with free will and with the genuine openness of the future. The objection goes like this: if the future already exists in the space-time block, then what I do tomorrow is already there, already fixed. My choice of what to do tomorrow is not really a choice, because the outcome already exists. The block universe implies fatalism. Everything is already determined, so nothing I do matters. This objection conflates the existence of the future with the determination of the future. Let me disentangle them. Determination means that the future state of the universe is derivable from the present state by the laws of physics. If the laws of physics are deterministic, then in principle the future is derivable from the present. If the laws of physics are non-deterministic, as quantum mechanics suggests, then the future is not fully derivable from the present. Existence means that the future events are real features of the space-time manifold. This is independent of whether they are determined. Even if the quantum mechanical evolution is genuinely non-deterministic, the outcome that actually occurs becomes part of the space-time block. The block is not a prediction of what will happen, it is the record of what does happen, including all the choices that are made, all the quantum events that occur, all the outcomes that are realized. The block universe does not say that your future choices are already made before you make them, in the sense that they are decided by factors beyond your control. It says that your future choices, when you make them, are events in the space-time block. The making of the choice is a real physical event. The content of the choice is determined at the moment of making it by whatever processes determine your choices, whether those are deterministic neural processes or genuinely non-deterministic quantum events or some combination. The block universe is not more threatening to free will than the non-block universe. In both cases, the physical processes that lead to your choices are what they are, and the question of whether those processes are free or determined is independent of whether the outcomes of those processes are already in the space-time block. Let me now describe an experimental context in which the block universe becomes most vivid and most testable, which is the behavior of entangled quantum particles across large distances. In 1935, Einstein, Podolsky, and Rosen published a paper arguing that quantum mechanics was incomplete. Their argument was based on a thought experiment involving two particles that are quantum mechanically entangled. Their quantum states are correlated in such a way that a measurement on one particle instantaneously affects the quantum state of the other, regardless of the distance between them. Einstein called this spooky action at a distance and argued that it was inconsistent with the principles of special relativity, specifically with the principle that no signal can travel faster than light. John Bell formalized the argument in 1964, deriving inequalities that any theory with local hidden variables must satisfy. Local hidden variables would be the information that determines the outcomes of measurements, but that quantum mechanics does not represent. If the measurement outcomes were determined by local hidden variables carried by each particle, the correlations between outcomes could not exceed the Bell inequalities. Quantum mechanics predicts correlations that violate the Bell inequalities. Experiments beginning with Alan Aspect in 1982 and culminating in the loophole-free Bell tests of 2015 by groups in Delft, Vienna, and NIST have confirmed that the Bell inequalities are violated by quantum systems exactly as quantum mechanics predicts. The correlations between distant, entangled particles cannot be explained by local hidden variables. Whatever's going on in quantum mechanics, it is not explicable by local, predetermined properties of the particles. The Delft experiment achieved violations at 3.9 sigma with both loopholes closed. The Vienna photon experiment achieved violations exceeding 10 sigma. The conclusion is definitive. Local realism is ruled out by experiment. What does this have to do with the block universe? The non-locality of quantum mechanics, the fact that distant, entangled particles show correlations that cannot be explained by local hidden variables, fits more naturally into the block universe picture than into any alternative. In the block universe, the correlation between two entangled particles is a feature of the space-time block. The measurement events on both particles are already related by the quantum entanglement, which is a non-local feature of the quantum state. The correlation is not produced by a signal traveling from one measurement event to the other. It is a feature of the joint quantum state that is already present in the structure of the block. In a presentist or growing block view, the non-locality of quantum mechanics is more difficult to interpret. If only the present exists, the measurement on the far particle happens after the measurement on the near particle. The correlation between them must be produced by some mechanism that connects the two events. If that mechanism is the quantum state must somehow reach the far particle before it is measured, which requires a specific sense in which the quantum state exists everywhere at once at the present moment. But the relativity of simultaneity means that the present moment is not universal, making this interpretation problematic. The block universe provides the most natural framework for quantum mechanics, including its non-local correlations. The quantum state of the universe is a feature of the entire space-time block. The correlations between entangled particles are features of the quantum state, present in the block regardless of when the measurements are made. The relationship between quantum mechanics and the block universe connects to the deepest questions about the interpretation of quantum mechanics. In the many worlds interpretation, developed by Hugh Everett in 1957, every quantum measurement causes the universe to branch into multiple worlds, one for each possible outcome. The wave function never collapses. Instead, the universe splits. In this interpretation, the complete block universe contains all the branches, the entire branching tree of all possible measurement outcomes across all time. The block is the maximal structure, containing not just the sequence of events in our world, but all the branches in the full quantum many worlds. In the Copenhagen interpretation, the wave function collapses upon measurement and only one outcome is realized. The block universe in this interpretation contains only the actual outcomes, not the unrealized possibilities. The collapse occurs at a specific moment in the present, which creates tension with the block universe picture, since the present is not universal in special relativity. The pilot wave interpretation of de Broglie and Bohm gives particles definite trajectories guided by the wave function. In this interpretation, the block universe contains both the particle trajectories and the guiding wave function, but the guidance equation requires a preferred reference frame which sits uncomfortably with the relativity of simultaneity. Each interpretation has a different relationship to the block universe. The many worlds interpretation fits most naturally, since the full branching structure exists as a complete four-dimensional space-time object. The Copenhagen and pilot wave interpretations have tensions with the block universe that have not been fully resolved. What all interpretations agree on is that the experimental facts established by the Bell tests, that quantum correlations cannot be explained by local hidden variables, require something beyond classical local realism. The block universe, with its non-local four-dimensional structure, is the natural geometric framework for hosting whatever the correct interpretation of quantum mechanics turns out to be. Let me now close with what I think is the most important thing to understand about the future already existing, which is what it means for the felt experience of being alive. The block universe picture does not diminish the importance of the present moment. The present moment, the specific event on your world line that you are currently experiencing is real in the block universe. Your experience of it is a physical event with genuine causal powers. It determines what the next moment on your world line will be, at least statistically. The choices you make, the actions you take, the thoughts you think are physical events in the space-time block that have causal consequences for subsequent events in the block. The block universe does not make the present moment less significant. It changes what the present moment means. In the standard non-block view, the present is significant because it is the only moment that exists. In the block universe, the present is significant because it is the moment of causal agency, the moment at which your physical processes are producing the next events in the causal chain that leads forward along your world line. I've described the block universe primarily in the context of special relativity, with its flat Minkowski space-time and its constant velocity observers. But the full physical picture requires general relativity, which introduces gravity and curved space-time. Let me describe how the block universe extends to the full relativistic context, because the curved space-time of general relativity adds additional richness to the picture. In general relativity, the space-time manifold is not flat. It is curved by the distribution of matter and energy according to the Einstein field equations. The Ricci curvature tensor minus 1/2, the metric times the Ricci scalar, plus the cosmological constant times the metric equals 8 pi g divided by c to the 4th times the stress energy tensor. The curvature of space-time determines the trajectories of freely falling bodies, which follow geodesics, the straightest possible paths in the curved geometry. The block universe in general relativity is a curved, four-dimensional manifold, not the flat Minkowski space-time of special relativity. The world lines of observers are curves on this manifold. The proper time along each world line is the length of the world line in the curved metric. Near massive objects, where the space-time curvature is large, the metric is significantly different from the flat Minkowski metric, and the proper time accumulated along world lines is modified accordingly. The most dramatic consequence for the block universe is that in general relativity, the future of a given event is not just the region of space-time in the forward light cone of that event. The causal structure of the space-time is modified by the curvature. Near a black hole, the interior of the event horizon is a region of space-time that is in the causal future of events outside the horizon, but from which no signal can reach the exterior. The block universe near a black hole has a specific structure in which the interior events are in the future of exterior events, but are causally disconnected from the exterior's future. The singularity at the center of a black hole, where the curvature becomes infinite and the classical description breaks down, is a feature of the block universe at a specific location, the end point of all world lines that enter the black hole. The singularity is not a place but a time, in the sense that it is the future boundary of the space-time manifold for observers inside the horizon. In the Schwarzschild solution, the interior of the black hole is a space-time region in which all time-like world lines hit the singularity in finite proper time. The singularity is in their future, but it is not a point in space. It is the end of time for those observers. This is one of the most striking features of the block universe in the context of general relativity. The block has boundaries, places where the classical description breaks down and the geometry is no longer well defined. The singularities of general relativity are not just physical mysteries. They are structural features of the space-time manifold, places where the block ends or is not well defined. The resolution of these singularities is expected to come from quantum gravity, the theory that I described in the Final Secret video. In the full quantum gravity theory, the singularities of classical general relativity would be replaced by non-singular quantum structures. The block universe of quantum gravity would be a quantum space-time without the classical singularities, with a structure at the Planck scale that the classical geometry cannot describe. The block universe, in the context of quantum gravity, is not the classical four-dimensional manifold of Minkowski space-time or the curved manifold of general relativity. It is the quantum state of the geometry, a wave function over all possible spatial geometries, evolving according to the Wheeler-DeWitt equation or its string theory or loop quantum gravity analog. The block in this sense is the full quantum spacetime, with all its quantum fluctuations, all its superpositions of geometries, all its Planck scale structure. The question, what does the future already existing mean in quantum gravity, is one that current physics cannot fully answer. In the classical block universe, the future is a definite region of spacetime with definite geometric properties. In quantum gravity, the geometry is uncertain at the Planck scale, and the future may be a superposition of many possible geometrical configurations. Whether the future in quantum gravity is as definite as it is in classical general relativity, or whether quantum indeterminacy fundamentally changes the picture, is an open question. What can be said is that the basic argument for the block universe from the relativity of simultaneity is not a statement about the classical geometry specifically. It is a statement about the non-universality of the present moment, which follows from the Lorentz symmetry of space-time. Lorentz symmetry is not just a feature of flat space-time. It is a local symmetry at every point of the curved space-time of general relativity. Locally, in any small region, space-time is approximately Minkowski, and the relativity of simultaneity holds. The argument for the block universe from the relativity of simultaneity therefore holds locally at every point of the curved space-time, even if the global structure of the curved space-time block is more complex than the flat Minkowski case. The block universe, in the full context of general relativity and with the perspective of quantum gravity, is a more complex and less completely understood object than the simple four-dimensional slab that the Minkowski picture suggests. But the core claim that the future already exists, that there is no universal now, that past and future events are equally real, is supported by the physics at every level of description currently available. Let me now return to the question of what the block universe means for the lived experience of time and develop it in more depth than I did in the earlier section, because I think there are specific aspects of the emotional and philosophical implications that deserve careful treatment. The most common response to the block universe among people who encounter it for the first time is unease. The future already exists sounds like a removal of something essential, the openness of the future, the sense that what happens next is not yet decided, the feeling that choices matter because they determine what comes next. If the future is already there, what is the point of choosing? If the outcomes are already fixed in the block, why deliberate at all? I have addressed the philosophical response to this, the compatibilist argument that the existence of the future in the block is compatible with free will. But I want to address the emotional response separately, because the emotional response is often not resolved by the philosophical argument. The emotional unease with the block universe comes from conflating two different senses of the word already. When I say the future already exists, I do not mean that the future is already known, that it is already decided in some external sense, or that it is already determined by factors outside of your control. I mean that the events that will constitute your future have a place in the space-time manifold, just as the events that constitute your present and your past do. The difference between the future and the past in the block universe is not ontological. Both are equally real in the block. The difference is causal. You are causally connected to your future, but not to your past, in the specific sense that what you do now affects what happens to you in the future, but does not affect what happened to you in the past. Your present actions are part of the causal chain that produces the events that will be in your future. The fact that those events are already in the block does not remove your causal role in producing them. It just means that the universe is complete enough that those events have their space-time coordinates, whatever those coordinates turn out to be. The emotional analogy that I find most helpful is this. Consider a book that has already been written, sitting on a shelf. The words on every page already exist. The events of the novel are already there. Yet when you read the book, you experience the events in sequence. You feel suspense about what will happen next. You are genuinely surprised by plot turns. The fact that the future of the narrative is already written does not deprive you of the emotional experience of reading it. Your life in the block universe is like reading a book that has already been written by the causal processes of physics, including your own deliberation and choice. The events are already there in the block, but you are inside the book, not outside it. You experience the events in sequence. You feel genuine suspense about what will happen. You are the protagonist of the narrative, and your choices genuinely shape which plot turns occur. The block universe does not put you outside the book. It tells you that the book is complete, but you are reading it from the inside. This is not a perfect analogy. The author of a conventional novel is a conscious agent who determines the events independently of the characters. In the block universe, there is no author external to the story. The events in the block are determined by the causal processes within the block, and you are one of those causal processes. Your deliberation, your choices, your actions are physical events within the block that determine what other events occur. The block is not written by an author who is separate from you. It is written by the physics, including the physics of your own neural processes as the causal chain unfolds. The block universe is more like a self-writing book in which the events at each page are causally produced by the events at the previous pages, including the deliberations and choices of the characters. The events are already there in the complete book, but they are there because of the causal processes within the book, including the characters' choices. You are one of those characters. Your choices are part of what writes the book. This is the honest picture that the physics provides. It is not as comfortable as the picture of a future that is genuinely open in the sense of being empty, but it is more complete, more interesting, and more consistent with what the mathematics of space-time actually says. The future already exists. Your choices already determine it, and you are traversing it right now along your world line in the only direction that the thermodynamic gradient of this specific region of the space-time block allows. That is the truth about time that nobody told you. It is worth sitting with. It is worth letting settle, and it is worth living in light of. The block universe, in all its strangeness and completeness, is the physics of time taken seriously. And the 12 principles in my book are about exactly that. Taking the physics seriously all the way down to the point where it changes not just your abstract understanding, but your relationship to the moments you are living. Ready to change how you see the world? Get 12 principles for understanding the fabric of reality at realityprinciples.com. The future already exists does not mean your future is fixed. It means the future events, whatever they are real features of the space-time manifold. The content of those events is determined by the causal processes that produce them, including your choices and actions. You cannot experience the future before it is in your past on your world line, but you can affect what that future contains by what you do now. There is something deeply liberating about the block universe picture for me personally, and I want to share it. The past does not cease to exist when it passes. The moments of joy, connection, meaning, and love that you have experienced are not gone. They are permanent features of the space-time block. They exist at their space-time coordinates, just as your childhood bedroom exists at its space-time coordinates, just as the moment you first understood something beautiful about the world exists at its space-time coordinates. The past is not lost. It is fixed in the block, as real as the present. This is not a consolation about memory, about the fact that we can remember the past. It is a claim about the structure of physical reality. The past events are real right now at their space-time coordinates. They are not merely remembered. They are present in the universe at a different location in the space-time block than the present moment, but no less real for that. The same is true of the future. The moments of joy, connection, meaning, and love that are in your future already exist in the space-time block at space-time coordinates that you have not yet traversed, you will traverse them along your world line. The traversal is what you call living. But the experiences that await you in the block are already there, already part of the universe, already as real as anything you have experienced before. This changes the emotional relationship to time in a specific way that I find profound. The grief of losing a loved one, the sense that they are now gone and no longer exist, is softened by the block universe picture. They exist at their space-time coordinates, which are now in your past. They're not gone from the universe. They are fixed in the block, as real as ever, at the events that constituted their lives. You cannot return to those events along your world line because world lines are one-directional in proper time. But the events are there. The anticipation of events in the future, the worry about what might happen, the hope for what might be, takes on a different character in the block universe. The events that will occur already exist. They are already features of the space-time structure. Whether they are good or bad is determined by the causal processes that will produce them, which are themselves already unfolding. The future is not open in the sense of being empty, waiting to be filled by the choices and chances of the present. It is already there, already full, already as real as the present. What you experience as the openness of the future is simply the boundary of your knowledge, not the boundary of what exists. I recognize that this picture is challenging. It sits in tension with deep intuitions about time that are embedded in our language, our experience, and our culture. The sense that the future is open, that the past is fixed, that only the present is real, is so fundamental to human experience that questioning it requires deliberate effort. But physics has repeatedly asked us to question our deepest intuitions about the nature of reality. The earth is not flat. The sun does not move around the earth. Matter is not continuous. Light is both wave and particle. Energy comes in discrete packets. Space and time are a single, four-dimensional manifold. The future already exists. Each of these claims was counterintuitive when it was first established. Each required abandoning an intuition that had seemed obviously correct. And each revealed a universe that is more interesting, more strange, and more worth understanding than the intuition had suggested. The future already exists is the same kind of claim. It is not comfortable. It does not fit neatly with the felt experience of being alive in time. But it is what the mathematics of space-time says, and the mathematics of space-time has been confirmed by a century of the most precise experiments ever performed. The truth about time that nobody told you is this: you are not moving through time from a real present into a non-existent future. You are moving through a space-time block that is already complete, already present in its entirety, already containing every moment of your past and every moment of your future at their respective space-time coordinates. Your experience of time is real. Your choices are real. Your past is not gone. Your future is not empty. Everything is already there. The most profound implication of the block universe is not that the future exists. It is that existence is not the same as being present. The universe does not consist of only what is happening right now. It consists of the entire four-dimensional structure of space-time, with all its events, all its histories, all its futures, all its possibilities realized in specific outcomes at specific space-time points. Reality is richer and stranger and more complete than the present moment suggests. And you, moving through this block along your world line, accumulating proper time, making choices, and experiencing consequences, are not an observer of reality from the outside. You are a physical structure within the block, a pattern in the space-time manifold, made of the same matter and governed by the same laws as everything else in the universe, traversing your particular path through a reality that already contains your entire story. The question of what that means for how you live is not a physics question. Physics describes the structure. What you make of the fact that the future already exists how you relate to the impermanence of the present and the permanence of the past, how you find meaning in a universe that is already complete at the cosmic scale while remaining genuinely open at the level of your own agency and choice, is a question that physics hands to you and that you must answer for yourself. The 12 principles in my book are about exactly this: the interface between what physics has established and how one lives in light of it. Ready to change how you see the world? The future that already exists in the space-time block includes the moment when you read those principles and something in your thinking shifts. Get 12 principles for understanding the fabric of reality at realityprinciples.com. What does it mean to you that the future already exists? Tell me in the comments. If this changed how you think about the nature of time in the future, if the block universe picture looks different after understanding the relativity of simultaneity and the thermodynamic origin of the arrow of time, if the permanence of the past and the already existence of the future changes your emotional relationship to the moments you are traversing, tell me in the comments. Tell me whether the block universe makes you feel more or less at peace with the passing of time. Tell me whether you find the conclusion that the future already exists liberating or disturbing, and why. And subscribe if you want to keep going into the places where the physics of the universe meets the most intimate questions about what it means to be alive within it.